This video will talk about finding angles and sides using trig. So our first note here is that we're going to use this acronym called Sohcahtoa, S-O-H-C-A-H-T-O-A, Sohcahtoa, where S stands for sine. And the trig function that you'll see on your calculators is S-I-N. Please don't call it sin. Sine is actually S-I-N. We just shorten it because we're lazy mathematicians. C stands for cosine. We shorten this by using just C-O-S. Again, don't call it cos, it's cosine. And T stands for tangent, abbreviated by T-A-N, not tan, but tangent. Then you see these O's, A's, and H's, where O stands for opposite, A stands for adjacent, and H stands for hypotenuse. So then there's just some steps here listed for you. It says whether you're finding sides or angles, the process begins the same. You start by circling the angle, labeling the sides as O, H, and A, and then based on the side labels, determine which trig function you use. If you're finding sides, you're going to go for a proportion. If you're finding angles, you're going to use inverse trig. Now, regardless of what you use, whether it's for sides or angles, you need to make sure your calculator is in degree mode. If you're not sure how to change it, ask a teacher around you or Google it. Alright. Then the last step here says to round appropriately. So whether it's to the 10th, the 100th, the whole degree, whatever it is, make sure you're rounding appropriately. Sometimes we have to use the Pythagorean Theorem to find a missing side length, and that's just your typical a squared plus b squared equals c squared. So we've got a couple of quick examples here just to get us based with the foundation of labeling O, H, and A. So here it says that we're based on angle C, or focused on angle C. So again, start by circling the angle, then we're going to label some sides. The hypotenuse is always across from the right angle, so find your right angle and label the side opposite of that as H for hypotenuse. The side touching the angle right here is called adjacent because it's next to. The side opposite, meaning AB, is your opposite because it's, well, opposite of angle C. And you could think of like dragging your pen or your pencil across your paper to the opposite side of the triangle. Now the next one says that we are focused on angle A. Circle the angle and start labeling the sides. Go ahead and do that and then check back in with me. So I found AC, the 29, to be H, the hypotenuse, the biggest side, the 21 to be O, and the 20 to be A for adjacent. Now there's one more important piece of information here. Angle of elevation, means to look out and up. Elevate means look up. Depression means to look out and down. And you can see these pictures here. We start for angle of elevation by looking out and then up. For depression, we start by looking out and then down. If you flip it to the next page, we've got some Common Core questions coming at us. After I give you some examples. Now, I'm not going to go through all of these thoroughly, but they are here. They are full, complete examples of finding a side, finding an angle, and finding a side using Pythagorean Theorem. So you're welcome to refer back to this if you need help throughout your practice. Now again, these questions came from Common Core exams. So this first one was a 2-point short answer question. A carpenter leans an extension ladder against a house to reach the bottom of a window, 30 feet above the ground. So here's the bottom of our window, 30 feet off the ground. As you can see, it's already labeled. I'm just going to carry that height over here. As shown in the diagram below, the ladder makes a 70-degree angle with the ground. So angle with the ground and the ladder, 70 degrees. To the nearest foot, determine and state the length of the ladder. So I'm going to choose to call this x. So again, we start by circling our angle, 70 degrees. Then we label our sides OHA. O for opposite, A for adjacent. Well, my adjacent side doesn't have a length on it, nor do I care about it, so I'm not going to label it. I'm only going to label the ones that I actually need or are given. And biggest side is the hypotenuse. So if I think of Sohcahtoa, O and H force me to use the S. Remember that S stands for sine, and we abbreviate it by SIN. Parentheses equals a fraction. Inside the parentheses always goes your angle. Outside the parentheses on the other side, we talk about side lengths. Opposite, 30, over hypotenuse, x. Because we're finding a side, not an angle, a side, we put this over 1 and we cross multiply in order to solve this proportion. So we have x times sine of 70 equals 30. Notice that I put the x out in front. Even if I were multiplying by a number, I would also put that number out in front, just so I don't get confused with multiplying it with the 70, because the 70 is separate. Now my goal is to get x by itself, so in order to do so, I need to divide by sine of 70 on both sides. So here, on the left side, they cancel. That's why we did it. And on the right side, this is what I'm going to type into my calculator, making sure that my calculator is in degree mode. So I'm typing 30 divided by, if you have a TI Inspire, you need to hit the trig button in order to bring up your trig options. 30 divided by sine of 70. 31.9253. And then it says rounded to the nearest foot, a whole number, meaning 30, well, is it 31 or 32? Now here I take the 1, look to the right, 5 and above, give it a shove, 4 below, let it go. This 9 is above a 5, meaning that the 1 changes to a 2. Round up. Number 2, again, another Common Core question. Says that the diagram below shows a ramp connecting to the ground, a loading platform that's 4.5 feet above the ground. So it looks like that's already labeled for us. The ramp measures 11.75 feet from the ground to the top of the loading platform. Determine and state to the nearest degree the angle of elevation formed by the ramp and the ground. So here's my ramp, here's my ground. Angle of elevation means to first look out and then look up. And we're going to call this theta. That symbol I just drew looks like this. It's called theta. And theta just represents an angle. If you really hate theta, call it x. No big deal. Theta just typically represents angles in math, so we choose to use it here. So now I start by circling the angle, labeling my sides OHA. You can go ahead and do that, then just check back in with my paper. Now I'm thinking Sohcahtoa. So if I have, again, O and H, that forces me to use sine. It is not always sine, by the way. It's just these two first examples happen to have sine. So again, inside the parentheses always goes the angle, and in this case, it's theta. Outside the parentheses are our side lengths. Opposite over hypotenuse. Now if you refer back to the notes we did at the beginning, if we're trying to find an angle, theta or x, we have to use inverse functions. So notice that as I pull theta outside the parentheses, I switch the sign, not plus or minus, but actual sign, trig, to the other side of the equals. As I do that, you'll see that I put this -1 here. That means inverse. Sine to the -1 means sine inverse. Don't ever say sine to the -1. That sounds lame. Call it sine inverse. and then parentheses, and we write the side lengths inside now, because they are the only thing that's left over. So in our calculator, we are typing in sine inverse of 4.5 over 11.75. And you can get the sine inverse button just the same way that you did for the sine button earlier by hitting trig. Again, that's only if you have a TI Inspire. If you have a different type of calculator, you may need to ask the math teacher that's near you. So when I typed it in, I got 22.5183, and we are rounding to the nearest degree. So again, figure out, are you keeping it at 22 or are you rounding up? I'm choosing to round to 23 because of that decimal 0.5. Number 3. As shown in the diagram below, the angle of elevation from a point on the ground to the top of the tree is 34 degrees. Angle of elevation means look out from the ground, look up to the top of the tree. If the point is 20 feet from the base of the tree, what is the height of the tree? So this point way out here is 20 feet from the tree, and we're looking for the height to the nearest tenth. So I'm going to circle my angle, label my sides, and solve for x. Alright, so I've got Sohcahtoa written out here. This time I labeled the tree as opposite and this 20 as adjacent, so O and A forced me to use toa. In other words, tangent of my angle equals my sides. Tangent of 34 equals opposite over adjacent. Because we're solving for sides, we put it over 1. Cross multiply. So now I have x equals 20 times tangent of 34. In this case, we can straight multiply this in our calculator. 20 tangent 34. Because there's no division to get x by itself. When we type it in our calculator, we end up with 13.4902, rounded to the nearest tenth, it said. So the 4 is my tenths place. Look to the right. 5 and above, give it a shove. So that means I have x equals 13.5. Choice 3. Now number 4 was not a Common Core question, but I did want to talk about this angle of descent that they're showing in this diagram. It says use the dimensions below, and what is the airplane's approximate angle of descent? Now angle of descent means the same thing as angle of depression. Look out and then look down. So our goal is to find that angle, which I'm going to choose to call theta. But if you look at the picture, our triangle that is actually physically drawn there is kind of upside down. But if you recall, if we have a line that's parallel to another line with a transversal drawn, these two angles are congruent. And that's because alternate interior angles are congruent. So if I label this angle of descent up there as theta, then that means that this angle of elevation down here is also theta. So we can use this theta in red to circle and label our sides. So we have 27.4 is adjacent, 30 is hypotenuse. If we look back at number 3 for our Sohcahtoa, A and H force us to use cosine. Cosine of something equals fraction. See if you can fill in those blanks. Then just bring your eyes back up to here to the board to see if you're correct. Alright, so I have cosine of theta equals 27.4 over 30. And in order to solve for theta, remember we take theta outside, we bring cosine to the other side while applying the inverse. And then of 27.4 over 30. Go ahead and type that in your calculator. Remember, inverse functions are the same button as normal trig, on a TI Inspire that is. So I found theta equals 24.0299 rounded to the nearest degree would then give us theta equals 24 degrees. So this was our last practice problem, our last problem of the notes, and now you're moving on to practice. Remember to refer back to any of the notes that we've done. You're welcome to rewind the video if you need to do so.